full wave rectification. So देखो full wave rectification is performed by a kind of a circuit called bridge circuit. ठीक है, तो bridge circuit सबसे पहले तो हम draw कर लेते हैं. And the circuit is drawn with four number of diodes, an input source, an AC, of course, and then four. These are the four diodes A, B, C, D. Okay. And anyways, so first of all, let's talk about the input voltage that we provide. Suppose what I do, I connect here a CRO, cathode ray oscilloscope, that will show me the input waveform. On the other side, I connect another CRO to my load resistor that will give me the waveform of the output voltage. So input I provide, and after the input pass through this bridge circuit, it provides me output, and output will be drawn as well. Anyway, so first of all, what oh, the graph of input voltage time graph, like it's going to be simply a sine graph like this. Okay, this is going to be an input. On the other side, we are going to discuss when this input passes through the bridge circuit, so what kind of output it provides. Anyways, let's talk about the current. For example, the current travels, first of all, let's say in this direction, and the current means, the conventional current, a positive pulse travels in this way, and it reaches this point, and this point, is called junction. Okay, and at that junction, the current will tend to divide, and some part of current will go this way towards diode B, and the other one goes this way towards diode. See clearly that one of the diodes between A and B is going to be forward biased, and the other is going to be reverse biased according to this red colored pulse. Okay, and what I see, because if the diode is like this and the pulse is going this way, forward biased, and when diode is like this and pulse is going this way, means reverse biased. In forward biased current is allowed, reverse biased current is not allowed. So A diode will not allow the current to pass. That's the reason why no current will pass through diode A. There will be too high resistance and the current is blocked by A. So I am going to erase the pulse that is passing through A. No pulse will be passing through A. Only the pulse will be passing through B. And after it passes through P, again it will reach another junction. This is the junction, right? Okay. So when it reaches this junction, again, the current will tend to divide and some current will, other amount of current will, you know, tend to flow through this. So what I see again, C is going to be reverse biased and no current will flow through C. Current is blocked and only the pulse will pass through this path and reaches a point that I'm showing P is providing us positive voltage. So I just call it positive point. This is the point at which a positive pulse reaches. Okay, so this is the point, and I'm going to draw the output graph here. Indicates like this. This pulse, what was there in my input, I obtain it in my output as well after passing through series of diodes. I hope you understand that, right? Okay, fine. So, I'm going to follow this pulse and see the pulse is passing through the resistor, will go this way, and again will reach a junction. Even I'm going to change the color after it passes through the resistor. I'm going to change the color and I'm using green color to show you the other pulses after passing color. It reaches this junction. And now once it reaches this junction, so both the diodes, in this case A and D, will start behaving like, you know, forward biased, but still the current will not be flowing through both the diodes. It will only go through one of the diodes, and one of the diodes is going to be D only, going this way, and will be going this way and will complete the circuit. Okay, so if you ask me the reason behind it, because some students ask, okay sir, if to flow through A and through D, why not through A? A is also looking like a forward bias diode for this pulse. Why the current does not flow through A, but it flows through D? Because on the path A, or on the path through A, the positive pulse is not being attracted. It is being repelled by the other positive pulses. See, if you talk about this path is taking the current towards the positive terminal. Although this is not the terminal, but right now we are assuming that this behaves positively. Okay, so do you think a positive charge can flow towards a positive terminal? Can a positive charge flow towards positive terminal? No, it will never flow towards the positive terminal. The reason is
Yeah.
the, कोई भी positive charge positive terminal की तरफ जा सकता है या नहीं जा सकता? Can a positive pulse
वो नेगेटिव
flow to?
टर्मिनल की तरफ जाएगा.
एग्जैक्टली एग्जैक्टली जाहिर है वो नेगेटिव की तरफ जाएगा, पॉजिटिव की तरफ नहीं जा सकता. ओके, सो दैट्स द रीजन व्हाई at this junction the current will not take this path. This path is not you know taken by current due to the same fact what I told you. Okay, वो जाएगा यहाँ पर, तो इसलिए करंट वापस आ जाएगा इस पॉइंट पे. तो मैं क्या करता हूँ, आई एम यूजिंग अनदर कलर नाउ and I'm going to show you the complete path of this current in case when is this point. The current flows like this, flows like this, flows like flows through the load resistor, and it flows this way, and this way. This is the complete path of a positive pulse that initiates or that leaves this point. Okay. Okay. So by the way, by looking at this circuit, by two diodes, what I'm circling in yellow, these two diodes are set forward biased. Okay, to the pulse, what is shown by yellow colored path, right?
Mm-hmm.
Okay, so I say B and D are forward biased, and the other one is going to be reverse biased, and these are reverse biased. ओके, सो बात ये समझ में आई कि इस पूरे ब्रिज सर्किट में जब पल्स किसी एक टर्मिनल से निकलती है तो कोई दो any two of the diodes are going to be set as forward and the rest of the two are set as reverse biased. क्या बात क्लियर हो गई आपको?
Yeah.
ठीक है, you know they ask you these kind of questions in the exam, right? Anyways, now what I'm going to show you, क्योंकि एक पल्स हमारी कंप्लीट हो गई, हमने discussed, okay, we obtain the same pulse as an output. Okay, now I'm going to show you another path of the current. I'm going to erase all that, and the other path of the current is shown like maybe like using another color, and that color is, let's say, black. Fine. Now positive pulse ऐसे जाती है, pulse ऐसे जाती है इस point पे, it reaches this junction. Keeping in mind, ये जो point नजर आ रहा है, जो आपको शायद point of intersection लगता है, ये वो point है कि जहां पर joint नहीं लगा है. Okay, like there is no connection. याद रखिएगा फिजिक्स में अगर हमें दो वायर्स को जो एक दूसरे के ऊपर नीचे से जा रही हो कनेक्शन शो करना हो तो वी शो अ ब्लॉब. ठीक है, ब्लॉब इंडिकेट्स के देयर इज जंक्शन, लेकिन अगर ब्लॉब नहीं है तो इसका मतलब देयर इज नो जंक्शन. एक वायर नीचे से जा रही है, दूसरी ऊपर से, तो यहाँ पर करंट का कोई पाथ जो है वो कनेक्टेड नहीं है. एनीवेज, यहाँ पहुंची है पल्स और पल्स पहुंच गई है इस पर्टिकुलर पॉइंट पे, और इस पॉइंट पे पल्स डिवाइड हुई एंड द पल्स टेंड टू फ्लो थ्रू सी एंड थ्रू डी. बताइए कौन से पॉइंट से या कौन से डायोड से पल्स पास हो जाएगी और कौन से नहीं हो पाएगी? Which one is going to be forward biased and which one is going to be reverse biased? What about C? C is forward or reversed?
इसके
इस पल्स के अकॉर्डिंग जो मैंने ब्लैक कलर एरो शो किया है, C से क्या करंट पास हो जाएगा? Yes, it is forward biased.
ये
And D is going to be reverse biased. So करंट यहाँ से आएगा इस टर्मिनल इस जंक्शन पे पहुंच जाएगा, B की तरफ नहीं जा पाएगा. Again, B is going to be reverse biased. So यहाँ से गुजरेगा and going this way and reaches this point, right? तो फिर से हमारे पास वो जो पॉजिटिव दिस वे, ये वाली नेगेटिव पल्स भी पॉजिटिव में कन्वर्ट हो गई, आप ये कह सकते हैं. ठीक है, एनीवेज, सो यू नो नेक्स्ट थिंग इज आई एम गोइंग टू कंटिन्यू, और ये पाथ यूं जाएगा और इस बार ये वाला नेगेटिव टर्मिनल है, तो इस बार ये वाले डायोड से गुजर के और यहाँ बस पहुंच जाएगी. व्हाट आई मीन, अगर मैं यहाँ पर पाथ शो करूं तो बल्कि मैं हाइलाइटर सेलेक्ट कर लेता
तो
हूँ.
20 से क्यों नहीं हो जाएगा?
हाँ, इसका आंसर फिर से वही है, क्योंकि अगर वो डी से गुजरा, ठीक है, तो जरा देखिए, मैं अगर एक रॉन्ग पाथ भी फॉलो करता हूँ
20 है नहीं 20 है.
बी से, अभी देखिए मैं बता देता हूँ. ये देखो, यहाँ तक तो पहुंच गए थे रजिस्टर तक, ऐसे आई यहाँ से पल्स इज फ्लोइंग थ्रू द रजिस्टर. ठीक है, अब जरा गौर से देखते रहिएगा, पॉइंट ए पे पहुंच गई है पल्स, आई मीन सॉरी, इस पॉइंट पे पहुंच गई है. अब या तो पल्स गुजरेगी डायोड ए से या गुजरेगी डायोड डी फॉर डॉग से, अंडरस्टैंड? ठीक है।
Yeah.
और इस बार ये जो ब्लैक कलर से मैंने एरो शो किया है, ये वाला पॉइंट, इस पॉइंट पे ये पॉजिटिव पल्स कभी भी नहीं आना चाहिए। इसका मतलब ये वाली पॉजिटिव पल्स कभी भी थ्रू डी से नहीं गुजरेगी, वरना वो दोबारा से पॉजिटिव पे पहुंच जाएगी। इसको तो नेगेटिव पे जाना है, राइट? तो इट विल फ्लो थ्रू
Hmm.
ए, यहाँ पहुंच जाएगी। अच्छा, फिर आपने पूछा बी से क्यों नहीं गुजरेगी? अगर बी से गुजरी फिर दोबारा इस पॉइंट पे पहुंच जाएगी, ठीक है? इसलिए बी की तरफ उसका फोकस ही नहीं है। फोकस होता है हमेशा ऑपोजिट चार्ज टर्मिनल की तरफ, राइट? तो इसलिए उसका फोकस होगा इस
Yeah.
पॉइंट के बाद ये वाला path and it reaches at this point, right? अगर मैं हाईलाइटर करूँ तो it will be like this, ठीक है? और यहाँ पहुँचने के बाद flowing through this, flowing through this, flowing through this, यहाँ पहुँचने के बाद it will flow through A, will be like this. ये उस पल्स का जो निकली थी नीचे वाले टर्मिनल से उसका पाथ है, ठीक है? अंडरस्टैंड? और जो ऊपर वाली पल्स थी उसका भी पाथ मैं यहाँ ड्रॉ कर देता हूँ ताकि आपको क्लियर रहे। जो नीचे वाली पल्स थी, ऊपर वाली पल्स थी जो यहाँ से निकली थी, उसका पाथ ये था, बी से गुजरा, यहाँ पहुंचा, यहाँ से गुजरा, ऐसे आया, यहाँ से गुजर के ऐसे आ गया। ठीक है जी। सो दोनों के पाथ बिल्कुल एक दूसरे से ऑपोजिट है। तो बात क्या समझ में आई कि जो इनपुट था हमारा वो आउटपुट में कुछ इस तरह से बन गया। इसीलिए इसको कहते हैं फुल वेव रेक्टिफिकेशन। पूरी की पूरी वेव जो है वो रेक्टिफाई हो गई है। ये हो गया वी टी ग्राफ is this one. I hope you understand that, right? ठीक है जी। अच्छा, ऑन द अदर साइड अगर हम बात करें कि हमारे पास ये जो आउटपुट में वोल्टेज आ रहा है, again this is going to be in the form of pulses, right? So if we want to convert into smooth voltage, so we have to connect a capacitor in parallel combination with the load resistor like this. Okay, so it's going to be smooth the voltage, and you know the smoothed voltage will be like this, going this way, like this again, going this way, okay, like this, going this way. This is going to be the smooth voltage, right? And smoothing, you know, is performed by a capacitor connected in parallel combination with the load resistor. And if you want to define the process of smoothing, so you can say that the process of decreasing variation, or you can call it of voltage in the load resistor. Okay, so this is the function of smoothing. तो अगर मैं कहूँ this is going to be P, this is going to be Q, this is going to be R. P is an input voltage, Q is going to be rectified, full wave rectified voltage, and R is going to be rectified and a smoothed voltage. Okay, so ये हमारे पास इसका पूरा complete process हो गया. I hope you understand that, right? Okay, so what I'm going to do for you, okay, and we'll be solving it. Give me a minute only. Okay, this is question number 18 of my worksheet, and it's going to be a bridge circuit, rectifier circuit, consists of four ideal diodes. Ideal means, they do not apply any resistance once they are forward biased, and they apply infinite resistance once they are reverse biased. Anyways, A, B, C, and D. are four diodes connected in a bridge circuit. They say an alternating supply is supplied between the terminals X and Y. They say on figure 6.1, label the positive means positive sign connection to the load resistor R. Okay, what we are supposed to do, we are supposed to find out what point of load resistor will provide positive pulse to the resistor. For example, if I label 2 points here, point number one, point number two, which point is behaving positively? Okay, so let's assume that the positive pulse leave this terminal X, it reaches a junction this point, and D is set as reverse bias, so it will pass through A. B is set as reverse bias once again, so the pulse will go this way and will reach at this point, right? So this is the point at which positive pulse will be provided to the load resistor. Even if I check it by another direction, if you think, okay, if by chance I just start the current from here, positive pulse, it will go this way, it will reach this junction. C is reverse bias, so it will pass through B and will reach point this, and again it you will be able to decide that this is going to be a positive terminal for load resistor. Okay, in any case this is going to be the positive terminal of the load resistor. I'm going to erase all that because I just label a point here and a positive sign. Next part, they ask you state which diodes are conducting when terminal Y of the supply is positive. Terminal Y of the supply is positive. See, this way, this way, this way. At this point, it goes this way, means B is going to be conducting, means forward bias, right? And it reaches this point, and this is going to go to this point, and pulse is flowing through this one. And after flowing through this one, what I'm going to do, I'm going to take the pulse at X towards X, right? That's the reason why through D it passes and you know it completes the circuit. And I hope you understand once again, see the path. अगर आपके जहन में ये बात आती हो कि ऐसे फ्लो करने के बाद यहाँ तक तो समझ आ गया, लेकिन इस जंक्शन पे तो दोनों फॉरवर्ड बाइज्ड हैं, तो मैंने आपको पहले बात बताई थी, हमेशा हम देखेंगे पॉजिटिव पल्स जो है इसका फोकस किस तरफ है। डेफिनेटली इसका फोकस है नेगेटिव टर्मिनल की तरफ, और इस टाइम पे जब वाई पॉजिटिवली बिहेव करेगा तो एक्स नेगेटिवली बिहेव करेगा, इसलिए ये पल्स चाहेगी कि ये सिर्फ और सिर्फ एक्स की तरफ जाए, तो इसलिए ये डी से पास कर जाएगी एंड इट विल रीच पॉइंट एक्स, तो ये हमारा पाथ हो जाएगा। It will be like this. I hope you understand that. Anyway, so the two diodes that are conducting in this situation are B and D. Next thing what they ask us is, okay, they have given us the rectified voltage and it's quite clear to us. Now they say use 6.2 to determine the mean power dissipated in the resistor R. This is the value of the load resistance, and they are asking us the mean power. Mean power definitely will be calculated by some of the formula. We are given R, and by looking at this graph we can find out V as well. So the formula for power in terms of V and R is V square upon R. But the question is raised, what V shall I take here? Shall I take here peak voltage? Shall I take here zero voltage? Shall I take here what? So if you remember in the last class, I taught you that there is an assumed voltage, assumed steady voltage, and that assumed steady voltage is called root mean square voltage, right? VRMS. So what I'm going to do, I'm going to take here RMS value that will be calculated by dividing square root of 2, okay, by dividing the maximum voltage, peak voltage by square root of 2. So 4 is the maximum voltage in V. So 4 upon square root of 2 is the RMS value. And I'm going to make it a square and I'm going to divide it by the load resistor. So please calculate what answer comes. Okay, the answer comes 2.96, 10 exponent minus
10 to the
3.
power minus 3.
Minus 3 watt. Okay. Okay, in the next part, they say on 6.1, draw the symbol for a capacitor connected so as to increase the mean power dissipated in the resistor R. Okay, uh, we have to increase the mean power, and we can increase it by decreasing the variation in the voltage, right? And that is performed by connecting a capacitor in parallel combination, isn't it? This goes for smoothing, right? And smoothing is a process of increasing the mean power. Anyways, so we have done this part three, I mean part two as well. B part two is done. Now they say the capacitor in B2 is now removed from the circuit, okay? And the diode A in 6.1 stops functioning so that now has infinite resistance, okay? So A stops functioning. Let's say A by mistake blows or stops working, and you can say that this point of the circuit becomes an open circuit, open path, you can say. There is a gap. So if there is an open circuit like that, so what happens in that case. In that case, one of the pulse is going to be present, the other of the pulse is going to be absent. How? I'm going to show you. For example, I remove all that, and okay, I removed it. Now see, suppose a pulse that is passing through this point reaches this terminal. A is going to be broken path, right? So pulse will not be able to flow through A. It will not be able to flow through D as well, because D is set forward reverse bias for this pulse, right? And the pulse will be absent. On the other side, if the pulse takes another path and it flows through this way, it reaches this junction. Yes, it will flow through B and it will pass through the resistor. Means this pulse is provided to the resistance R. Okay, it will flow through this one will flow through this one and will reach this junction, I mean this terminal X, right? So in this case, yes, pulse is obtained at output. So what I mean here, the pulses that are present, all the pulses are present. One pulse will be present, the other will get absent, present. You're going to trade absent, and this goes on and on. Okay, so this is how you are going to show the pulses if the if the diode A stops functioning. Okay, so this is how we do the last part, part C, and I hope you understand that, right?